Hassler here. I'm going to work through the 7.9 Explore. This will be day 1. There will be a second day, so I will make another video for that day. And you will need Desmos. As we work through these application problems or word problems for quadratic functions, we are going to use Desmos to help us find answers so that our focus can be on what we need to find based on what the question is asking. So the picture below shows a basketball player practicing basketball. The path of the ball is traced out by a parabola, so the graph of a quadratic function. Answer the questions that follow. Identify the parts of the parabola that correspond with each question. Okay, so the first question says, what is the maximum height of the basketball? And so when I look at this curve, I have this upside down parabola that traces out like this. And I apologize, I'm going to clear that screen. And I'm looking for the maximum height. So first of all, it looks like the x-axis has time in seconds. So I'm going to label that x. And the y-axis is height in feet. And so my height, I'm looking at the y value. And it looks to me like the highest the basketball goes is this point here. And if I trace that back, these are going by ones. This would be at 16. So 16, my label would be feet. And then the other question says, what part of the graph did you look at? And I want to be specific. So I'm looking at the vertex. And specifically, I'm looking at the y of the vertex because I'm looking at the height, which is a y value. B says, at what time does the ball reach the maximum height? Okay, so again, I'm still at this vertex, that maximum height. And if I bring that down, and it looks like I'm going by ones, I'm going to be at 9 seconds. So we're going to label that 9 seconds. And again, I want to be specific. So I'm still looking at the vertex, but this time it's the x of the vertex. All right, C says, at what time? So time's going to be an x value. Does the basketball go through the basket? Okay, so it looks like I'm going through the basket right about here, we'll say. And if I trace that across, I'm about 10.5 seconds. And so this is, what part of the graph did you look at? Well, we looked at an x coordinate because we're looking at time. I'm going to go across here to F since I can see that problem. It says, how long was the basketball in the air? Okay, so it looks like the height of the guy is here. He's shooting his shot, going through the basket, and then it's going to land over here on the ground. And it lands on the ground, that says ground, at about 21 seconds. And so the ball was in the air for about 21 seconds. And specifically, that to me looks like we're crossing the x-axis. And so, I technically over here, I would be crossing the x-axis as well. So this would be my second intercept. So we want to be specific with that. Okay, D says, at what height? So height is a y value. Does the basketball go through the basket? Okay, so C says, at what time does the basketball go through the basket? We said that was this point here. And at about what height? I'm sorry. Let's see. Oh, it looks like I switched this around. My apologies. This here would be the time, and I gave you a y value. So this right here, if we back this up, should be 16 seconds. And the height, which is a y value, should be here, which is 10.5 feet. My apologies. Can we go ahead and make that correction? Again, C says time. That should be an x value. And D says height. That should be my y value. That's what I get for trying to skip over. Okay. E says, how tall is the basketball player? So if I look at this basketball player, he looks like he's about, we'll say 6.5 feet. And what part of the graph am I looking at here? Well, it kind of looks like I'm looking at the y-axis. So I'm looking at the y-intercept. We only have one y-intercept. I only crossed the y-axis one time. All right, G over here says, at what time does the basketball 12 feet off the ground. Okay, so let's see. 12 feet would be right here. Looks like I'm 12 feet off the ground right there. But see, the basketball comes back down due to gravity, so I'm going to be 12 feet off the ground here. And so I'm looking for the x values that go with that. Looks like I'm at about 3 and 15. So 3 seconds and 15 seconds. And specifically, we found an x when y was equal to 12, okay? And it says, how high is the ball at 6 seconds? All right, 6 seconds would be here. And so if I trace up, how high is the ball? 15 feet. And it says, what did we look at? Well, we looked at the y when x was 6. Okay, so if we have a picture of the graph, I feel like we're able to pick out these important pieces that relate to features of the graph, such as the vertex, the x-intercepts, the y-intercept, an x value given a y value given an x value. It's a lot easier if we have the graph in front of us in order to answer those questions. And so just a couple quick notes that I want to take here. What we are talking about is something called projectile motion. In other words, we're looking at things that are being thrown up into the air. And so when that happens, they're going to go up and then gravity is going to pull them back down, giving us the look of a parabola over time. And some things that we want to note, we can find key points. So we are going to use graphs of quadratics to find key points. And so some key things that we're going to find would be the vertex. And I'm going to use in words what we would be looking for. So the vertex is going to give us the time of the max height, comma, that would be the x of the vertex, and the y of the vertex would be the max height. We're going to be looking for x-intercepts, and the x-intercepts can tell us a couple different things, and so we just have to pay attention to how it's worded. Sometimes it'll say something like time that we reached the ground, or I'm going to say /water. Sometimes we have dolphins jumping up or divers diving in, okay? Or it could say something like how long was that object in the air, like this basketball problem did. Okay, and so we're looking at when we hit the ground, okay, an x-intercept. The other thing that we might be asked to identify would be a y-intercept, and a y-intercept would be something like the initial height or the starting position. And again, we are going to use Desmos to help us graph so that we can think about what part of the graph is going to answer our question. So I'm actually going to go ahead and get you started on number 2 so you can see what the expectation is. This is the quadratic function h of t equals negative 4t parentheses 4t minus 5. Models the path of a dolphin, there we go, jumping out of the water, where t is time in seconds, and h of t is the height in feet. So you can use Desmos to answer each question. And so I did that here for you. We got ourselves set up on Desmos. And part A says, graph this on Desmos and sketch the parabola on the grid provided. Label your axes. Okay, so we're going to go over here to Desmos, and we are going to type in h of t. Now, Desmos will use x or t as the independent variable, so t is okay to use. Negative 4t parentheses 4t minus 5. And I have this nice little graph here. Okay, and so hit enter. And I need to make a sketch of this on my paper. So I'm thinking about points I could go through, 0, 0. It looks like I have a vertex at about, just past half, and then 6.25. I have a y-intercept at an x-intercept at 1.25. So I just want to pick some of these key pieces and plot them on my graph. I also need to label my graph. And so if I were to label, this is my t or x, and this would be h of t. T is time in seconds, and h of t is height in feet, okay? And let's get a little sketch going here. So we've got 1, 2, 3, and we've got 1, 2, 3, 4, 5, 6. And we said we have a point at 0, 0, point at about 1.25, and a vertex in between those. Something like this. Okay. And then B says, at what time does the dolphin return to the water? Okay. So this is where the dolphin is jumping out of the water. And so this is where the dolphin is going to return to the water. This T or x-axis is like my water. And so we had said that that would be our x-intercept. And when I look over here at Desmos, that x-intercept is at 1.25. And so it says, what part of the graph are you looking for? We're looking for that second x-intercept. And so numerically, t, that's what we're looking for, t, is 1.25, and then we want to label that answer seconds. C says, at what time does the dolphin reach the max height? Okay, so this would be the max height. But we're looking for the time, and the time is the x value. So if I come back over to Desmos, it looks like we've got the point, the ordered pair 0.625, comma 6.25. That should be easy to remember. Okay, so 0.625, comma 6.25. And so second part of what part of the graph are you looking for? We're looking for the x of the vertex. We're looking for time is always the x. And so t equals 0.625 seconds. What is the dolphin's max height? We are looking for the y of the vertex. And the y of the vertex was 6.25. Now this is a height, so we're going to say h equals 6.25 feet. And then at what time was the dolphin 4 feet in the air? Okay, 4 feet in the air would be right here. And it looks like the dolphin's going to cross through 4 feet twice, here and here. And that's because the dolphin is going to go from a height of 0 all the way up to a height of 6.25. So they're going to pass through 4 feet, and then gravity is going to pull them back down. And so I want to find that using Desmos, and I'm going to do that by typing in y equals 4. If I type in y equals 4, I get that horizontal line at 4, and then I'm able to see that I cross twice. I'm going to cross right here 4 feet, and I'm going to cross right here 4 feet. And so let's see what those x values are. It looks like I have an x value of 0.25, so at 0.25 seconds, and at 1 second. Notice that the y values are both 4. That's because at 0.25 seconds, I'm 4 feet above the water, where the dolphin is. And at 1 second, the dolphin is also 4 feet above the water, okay? And so what part of the graph are we looking for? We are looking for the time, so x, when y is 4, and that happened at 0.25 seconds. Should have an equal sign in there. And at 1 second. All right, I just want to do one more, start one more here with you. I don't want to do all parts of it, but I want to get the graph going for you so that I can show you how to use Desmos to fit things. So a tourist climbed to the top of a lighthouse and dropped her sunglasses. The height of the sunglasses in feet can be modeled by the h function, 100 minus 16t squared, where t is time in seconds since the sunglasses were dropped. So we want to graph this on Desmos. Okay, so I'm going to clear out what we have in Desmos. I am going to erase this stuff here. And I just want to type this in here for us. I'm going to again show you how this graph is going to work. And so again, we've got h of t equals 108 minus 16t squared. And I can see that it's off my grid, and I guess I could try to zoom out. That's zoom in, sorry. Zoom out, still zoom in. Okay, so I'm gonna hit the home key. So what I want you to do is take a note on what we're gonna do here. We're gonna hit this, it says edit list, but it looks like a wheel, like a setting. So go ahead and hit that. And you get these options, and we want this table option, create table. Now, what it does is it creates a table. But what I really want is this little button over here. It looks like a zoom in button, a magnifying glass. It says zoom fit. And if you hit enter or click on that, what it's going to do is it's going to give you points from your table, and it's going to zoom in on that graph so you get a better look of what that graph is without hitting the plus or the minus over on the left. And so I can see that I'm crossing the y-axis at 108. I have an x-intercept over here at 2.598, and I can use this to make my sketch. So go ahead and make that sketch, label your axes, see if you can answer parts B and C, and then your homework is to work on the 7.9 Delta Math practice.